Good afternoon. My name is Jamie Bascom. I am your student's teacher in chemistry. Our course is called, Chemistry in the Earth System, and I'm very excited. This school year is unusual, but I am very motivated to create a wonderful learning experience for your children, despite the fact that we're in the classroom and able to do hands-on labs. I'm going to talk to you a little bit about our organization for the course, some of the goals, and a little bit of what you can expect. Before I do that, I just want to introduce myself with this slide to introduce you to some of the people that matter a lot to me. I have my family here. This is my son Zenon, who's actually a freshman at Miramonte this year. And so I'm also like you, I'm a parent and I'm experiencing this also from that end. This is my son Finn and my husband Greg, and we're nature lovers, big hikers, and that's part of the reason why I ended up doing science, is my interest in the outdoors and the natural world. Before I was a teacher, I've been a teacher now for 8 years. This is my second year at Miramonte. But before I was a teacher, I was a scientist. I was a cancer biologist at Lawrence Berkeley National Lab. And something that really compelled me to transition and make a change and become a teacher was a need for bringing like a real lab experience to students. The reason for that is it was memorable to me when I was in high school that I didn't have much of a student experience doing science. It was very much about the teacher kind of presenting a lot of information. And it wasn't until I was actually a scientist that I realized, hey, this is quite different than what I remember in high school. Actually solving problems, actually having to plan out an investigation yourself, having to analyze your own data and how to, decide, how do you make sense out of this data? Is there anything to make sense out of this data? So I really want to bring a connection back to the actual of doing science and allow students to feel that. So that's why I'm here. Something that I started with in the beginning of the school year last week was this slide to emphasize to students that in order for you to be successful, some very simple things can be done that will really help you feel much more engaged. And so we've been, we can see into the homes of our students, and it's this, it's an uncomfortable kind of situation sometimes. You guys have this, wall behind me. I'm actually in my room, and it's hard to avoid things, but we're asking for students to do Zoom sessions, hopefully at a desk or at a table or standing but not in bed, to get ready for class just like you normally would by eating breakfast and getting dressed just like you would on a normal day so that they feel ready. And that goes for also getting organized like you would during the normal school year. And so I've been talking to students about organizing a journal for class and making sure that that's sitting right next to them during class period. And I'll talk to you about kind of what I mean by that, and to have their textbook nearby in case we're going to use that during the Zoom session, and other materials such as a calculator and of course something to write with. Open your mind. And so having this conversation with our students about engaging, and even though it feels like we're alone in some ways because it's often hard to participate in a discussion through the computer, but what we're asking our students and our families and ourselves is to try our very best to be positive about this experience and to bring your best when we're meeting together so we can have a hearty discussion and so that they can get the most out of it. In order to maintain focus, they need lessons that are not having them sit and just listening all the time. So something that I've tried to promise, and I'm going to try to uphold my promise to our students, is to not just solely create Zoom sessions that are lectures, but instead they're interactive, they're discussions where we're having lots of back and forth debate and inquiry and questioning because that's the whole point of us having synchronous lessons. All right, so these are some details about how things are going to go. The emphasis is on the next generation science standards, and so we are going to be doing the things that scientists do, such as asking questions, constructing models, arguing, but using evidence to base our arguments on. And so there's a total of 8 NGSS practices that you can take a look at if you would like to do that. I'm going to have those linked on the Canvas website. And also, we've incorporated all of those practices now into our grading. Okay, so we're actually using a standard-based grading in chemistry this year. There are 7 units of study, and chemistry in the Earth system, what that means is that we are doing foundational chemistry, but we are doing it in connection with the larger systems that and the larger cross-cutting concepts that they've been learning about since 9th grade in biology. So, for example, things like climate change and things like the carbon cycle, pollution, they were introduced to it in biology. And now what I've talked about this week is that we're going to be delving deeper. We're going to be looking at the level, the nanoscopic level, which means the level of the atomic, the atoms, the elements, the compounds, the molecules. We're going to be looking deeper at those things and seeing how, for example, the differences in molecules, however close in size, their structures, their shapes, could mean all the difference in the way they behave. This question that we posed this week is like, what's the difference between a greenhouse gas and one that is not? Okay, we have a lot of nitrogen that is perfectly, it's very present in our atmosphere. It's the highest percentage gas in all of the gases that we're breathing. And why is nitrogen not a greenhouse gas, but carbon dioxide is? And so we'll be posing questions like that in chemistry class and trying to understand what is it about some of their structures in that causes them to have different functions, different behaviors. All right, so labs are not completely out the window. We're going to try to have labs this year. We're going to do that a few different ways. We're going to have some virtual labs that are on the computer. We're going to have some labs where we're analyzing data. Okay, so we might demonstrate something and then present the data to students, and then we'll do the hard thinking, the careful thinking together through the data analysis and the calculation and the problem solving, the graphical analysis. But we're also going to maybe try to do a little bit of hands-on things at home. And so from time to time, I'll put together some bags and give the students just a few things so that they can go home and they can do some hands-on projects, because we really would like to try to get the students to be doing some hands-on work too, some kinesthetic work, and not just in front of the computer all day long. So there's going to be some work outside of the Zoom sessions, of course. There's going to be some, for example, asynchronous lessons on Monday. I'll talk about those in just a minute. But right now, I'm going to talk to you a little bit about the grading. You're going to see that the grading structure is based over here on the next generation science standards. And so different assessments will be designed that fit into each one of these categories. And since these are the things that scientists do, they're going to get ample opportunities at each one of these learning targets. And so there's going to be both formative and summative assessments that fall into these categories. The formative assessments will be 10 points, and the summative assessments are 20 points. So these are, like for practice. And then these are going to be more for, at the end of the unit to test their comprehension. Now, the summative assessments, we're going to allow for some revision there if the students need. And then there's going to be an opportunity to revise a summative assessment up to an 80% for increasing their grade. What are the types of assessments? The assessments might look like a little different than just paper tests because, quite honestly, it would be really hard for us to authentically grade paper tests given that the students are not with us and we're not able to have the ability to proctor a test, with just a pen and paper kind of thing. But we can do things like think aloud problem solving, where we hear the students explain their process. We can do things like have the students explain a short summary in an exit ticket, or provide a group response to some sort of scenario or some sort of problem that they had to work out together. I already mentioned virtual labs and questions and that sort of thing that come with that, and data analysis. There's also writing arguments, and some of these may just be in the form of like a short focused paragraph where they are trying to explain a phenomenon by using evidence from observations and data that they've been able to collect. All right. So a little bit that's offered on the syllabus that I'm not going to go into depth here. On the syllabus, there's classroom and Zoom behavior expectations. We've spent a lot of the first week working on just making sure the students know that in order for us to feel like we're in class, we have to have some expectations, such as the camera being on, such as having your proper name as your title, so that we can identify who's coming into the Zoom sessions and be safe in that regard. Some other things. So there's going to be resources on the syllabus, but I'm also going to be posting other ones on Canvas as I build my page up. And then there is also an explanation for the late work policy and for cheating on my syllabus. So, I feel like I'm pretty flexible with regards to late work, but I'm, trying to hold my students accountable. So I allow students to turn late work in, but I'm going to reduce the points by half. And if they have been absent, I'm going to give about 3 days for them to recover the work. Anyway, we'll move on to a little frozen here. So 1 second. Computer glitch. There we go. All right, I think the heat is melting my computer as we speak. Okay, so I wanted to talk to you guys a little bit about Mondays and what that's going to be for the students. It's a little different. Those are asynchronous lessons. So the students will have a piece of work that they're assigned on that day, but we're not meeting on the computer together. They might be meeting with some of their peers if they're working on a group work project. They might receive work in the form of a screencast lecture from me, maybe a reading assignment, maybe a problem set, maybe an introduction to a lab, but it's expected that they do work on Mondays and that they complete their work to be ready for our session, which would be Tuesday or Wednesday, depending on which period I have. And that's important because we don't want our Zoom sessions to be, again, just the teacher, but we want it to be interactive and to be a discussion. So we are asking that the students complete their Monday work to get ready for their first block day of the week. Okay, so I've kind of mentioned assessment already, but I just wanted to say that the units are going to be approximately 2 to 3 weeks. There might be a few longer ones that are almost 4 weeks long, and that we're going to have a summative assessment usually at the end of each unit, and then maybe like 1 to 2 quizzes or performance tasks that happen in the middle of the unit. So in total, there should be either about 2 to 3 summative assessments per unit. Okay, and then these are things that the students need for class. They need their textbook. They need a composition book for taking notes and to create a science journal from. And they need to bring their materials that we've prepared for them that's at Miramani to pick up. This is my last slide. This is my email, and please feel free to reach out to me if you have any questions whatsoever. I wish you all well, and take care.